Okay, Chemistry 111, this video is going to go over what you need to complete for lab number 8 or investigation number 8, which is molecular modeling. So it's called Molecular Geometries, a Molecular Modeling Experiment. And this experiment largely focuses on valence shell electron pair repulsion theory and hybridization. In the first part of your lab, you're going to choose one of these available compounds. You can see some of them are well known, like testosterone, morphine, cocaine. Some of them have some really interesting names, but you're going to pick one of these compounds and you're going to report a little bit about the chemical's history, its properties, structure, and you're also going to use your computer to become a molecular model builder using a program called MolView. And you can just send me an email to let me know exactly which compound you chose from the list of available compounds. After you've chosen a compound, in part A, you're going to report who discovered the compound and who synthesized it. You're going to provide its IUPAC name or its systematic name. You're going to report on its uses and provide at least one interesting fact about the molecule. After that, in part 2, you're going to use the program MolView to help you build a virtual model of your molecule. You're going to be shown the accurate bond lengths and bond angles, and then you want to take a screenshot and print it in color. You want to print both the 2D and the 3D models. Make sure to include the hydrogens on both. Then you're going to convert the molecule to a space-filling model. So this is under the Model tab, and it's called a van der Waals spheres model. And you're going to explain what that model is trying to show, and be sure to include a picture of that as well. After you've seen the three-dimensional structure in MolView, you're going to take the time to neatly draw the molecule in your notebook, and be sure to write down the molecular formula. You're going to label each atom's hybridization, use a specific color for sigma bonds, another color for pi bonds, label all of the bond angles, and create a legend so that it's clear what colors represent what, and be sure to add in lone pairs as well. Here's an example that was submitted by a student in a previous semester. The molecule they chose was serotonin, and you can see their color-coded legend here, which includes both sigma and pi bonds, the hybridization of their atoms, and all of the bond angles too. We are going to skip parts 4, 5, and 6, so you don't have to make a model at home, and you don't have to make any videos or comment on anybody else's videos. In part B, you're going to go to another site to get some help in filling out the table that's attached to your lab report. In the table, you're going to fill out the Lewis structures and put a 3D drawing for all the Lewis structures for all of the compounds in the table. You're going to include the Vesper class, the electron arrangement, which is the same thing as electron geometry, the molecular geometry. You're going to include bond angles, hybridization, and molecule polarity. Let's take a look at the table. And here is that table. You can either print it out and fill it in by hand as long as it's legible, or you can fill it out on your computer from the Word doc. So say, for example, you were doing carbon tetrachloride, and that's the example that's shown in here. They have a chlorine in the middle, which is a typo. It should be CCl4. First, you're going to tally up the number of valence electrons. Carbon tetrachloride has 32 valence electrons. Then you're going to do a 3D drawing of the Lewis structure like this. Make sure to use dashes and wedges where appropriate. You're going to include the Vesper class, the electron geometry or arrangement, which is tetrahedral for this one, tetrahedral molecular geometry, include that. You're going to include the bond angles, hybridization of the central atom, so this carbon is sp3 hybridized, and then you're going to determine whether the molecule is polar or not, and for that, a simple yes or no will suffice. And so you're going to fill all of these out for each one of the molecules in the table. So PCl3, PCl5, tellurium tetrachloride, ClF3, sulfur difluoride, xenon tetrafluoride, what else? Sulfur hexafluoride, aluminum chloride, hydronium, dinitrogen monoxide, xenon difluoride, ozone, CH2, 2-, IF5, and azide, N3-. As always, before you submit your lab, you can check the lab report checklist to make sure you have everything complete. And the only thing you don't have to complete from this checklist is the at-home model and the part about videos. But the rest of it is going to be included in your report. And that's what you need to complete for lab number 8, the molecular modeling home lab in Chemistry 111.